Today we're going to learn about finding our x and our y intercepts and how we can use these intercepts in order to graph lines that come in standard form. So let's just go with a little background of what we learned last year. Last year you learned how to graph a horizontal line. A horizontal line would be something like y equals either 4, as in our example, or another number. So let's look at that first. We have the equation y equals 4. So what we're going to do is we're going to graph the line y equals 4. We know it's a horizontal line, so we're just going to go up and say, okay, well, if y equals 4, first thing I'm going to do is put a dot on my y-axis at 4. And then I'm going to put other dots also on 4 so that I can draw my line. Okay, and that's a graph of my line, y equals 4. For every x value that we have, y equals 4. And if we look at it, our line is crossing the y-axis at 4. That's called our y-intercept. Okay, so now let's look at graphing a vertical line. Our vertical lines, they're not a function because they fail the vertical line test. And so they're always going to start with an x equals instead of our y equals that we're used to seeing. Okay, so here we know that x equals -2. So I'm going to put a dot. I'm going to go out my x-axis and I'm going to put a dot at -2. And then for every value of y that I can come up with, x is going to be -2. So I'm going to go ahead and draw my line for that. And if I look, this is crossing my x-axis at -2. That is my x-intercept. So the value of x is -2. Okay, so just from looking at this, can you start to get maybe an idea of what the term intercept might mean? From looking at what these two have in common, what intercept is going to mean, or what it does mean, is when your line crosses the axis. So in this first case, it's when our line crossed the y-axis, making it the y-intercept. And here it's where our line crosses the x-axis, making it the x-intercept. Okay, so a couple of things in vocabulary you need to know. First is standard form. Our standard form is ax plus by equals c, where a, b, and c are real numbers. We're going to be talking a lot about standard form, but when it's in standard form like this, it's very easy to find the x and y intercepts, which is what we're going to be doing today. So let's go back to that definition of x and y intercept. Our x-intercept, it's the point on the x-axis where our line crosses. So the point on the x-axis where our line crosses, so our x has a number, but when it crosses there, our y is a 0. So on our x-axis, or our x-intercept, it's always going to be when y equals 0. Oftentimes, the x-intercept is referred to as the 0 of the function. Okay, so along the same lines, our y-intercept. If we go back and look up here when we graphed our y equals line and had a y-intercept, our y-intercept, we have a number in the y value, and our x equals 0. So if we look at our graph right here, our little example graph, when we have a line going, where this line crosses the y-axis is our y-intercept, and where it crosses the x-axis is our x-intercept, or our 0. So let's just take a minute and look at number 4 and 5 and actually identify our x-intercept, our y-intercept, and our 0. So starting with the x-intercept. So we're talking about our x-axis. We want to know where our line touches or crosses, same thing, our x-axis. So in this point, it's crossing it at 30. So our value is 30. And what is y? Y is always going to be 0 in our x-intercept. Okay, now let's find our y-intercept. Make this a little bigger. Okay, our y-intercept. We're going to go on our y-axis and see where our line either touches or crosses the y-axis. And in this case, it touches it at 25. So our y-intercept is going to be the y value is 25, and this time our x value is 0. So the y-intercept, we have a value in y. The x-intercept, we have a value in x. And then our 0. Our 0 is always the x-intercept. So the 0 of this function is 30. All right, so I want you to pause the video and do number 5 on your own, and then come back and check your answer. Okay, so now let's move on to figure out how we can use our intercepts to actually graph lines. So first thing we have to do is figure out how to find our intercepts. So using what we just learned about what is a 0 and where the 0 goes in each of our intercepts, for our x-intercept, if you notice up here, for our x-intercept, y was always 0. So we're going to plug in a 0 for y, and then we're going to solve for x. We want an x-intercept. We're solving for x. And then when we do the y-intercept, it's going to be just the opposite. We're plugging in a 0 for x, because notice on our y-intercept, the x is what is 0. So we're going to plug in a 0 for x, and we're going to solve for y. So let's take number 6 and actually find this. So we're going to start by finding our x-intercept. So to find our x-intercept means we want to solve for x. So we're going to take our y and plug a 0 in for it. So we got 3x plus 4, but instead of a y, we're going to plug in a 0 equals 12. Okay, so just right off the bat, what is always going to be 0 times a number? 0, it goes away. So we know that we can go, that goes away, and we're really just left with 3x equals 12. It's a quick one-step equation. We divide both sides by 3, and our x-intercept equals 4. So we come up here, our x-intercept is 4, and we know our y is 0. Okay, now we have to do it again, but this time we need to find the y-intercept. So our y-intercept, we're solving for the y value. So we go ahead and plug in a 0 for the x. So I'm going to do that right over here. 3, plug in a 0 for the x, plus 4y equals 12. Well, I know right off the bat that I can just cross out this 3 times 0. So I'm left with 4y equals 12. When I divide both sides by 4, I have y equals 3. So my y-intercept is 3. So let's graph these guys. My x-intercept is going to be at the 4, 0. So it's going to be right there. And my my y-intercept is going to be at the 0, 3. So it's going to be right there. And then I can go ahead and just draw my line. My line goes right between them. Okay, and what is the 0 of this function? Where does our function hit our x-axis? Well, 0 of our function is 4. Okay, I'd like you to pause the video and practice the second number 6 on your own. Okay, verify that you graphed this one correctly. And then the question, how could you check to see if you graphed the equation correctly? Well, you could take another point on the graph, maybe like this point right here, 1 comma negative 2, plug that in for x and y, and make sure it equals 4. Okay, so let's go ahead and turn the page. And as we learned in our last class, functions are the same pretty much as equations. So the zero of a function is also called an x-intercept. Okay, so it's also called an x-intercept, but we're actually using function notation. So we have our y equals 0, but in function notation we would say that is f of x equals 0. Because remember from last class, this f of x is really the same thing as saying y. So to find the 0 of our function, we're going to plug in 0 for y. So then it gives us an example. Go ahead and pause your video and do this example real quick. Okay, so go ahead and check and make sure that you got the x-intercept, or the 0 of this function, as negative 2. So let's put this into real life situation. Let's talking about an artist renting a booth. So they've given us the equation, or the function, and they're asking us to find the 0 of the function. Okay, so to find the 0 of the function, we have to plug in 0 for our f of x, or for our y. So to find the 0, we're going to say 0 equals 50x minus 300. And we're just going to solve it for x. So we'll do plus 300 on both sides. And we've got 50x equals 300. Divide both sides by 50. And our 0 is x equals 6. So that's the 0. So what does it mean in this situation? Well, in this situation, what that means is this artist is going to have to sell 6 paintings before they start making a profit. So the first 6 paintings are really paying for the cost of that artist's booth.